Today we are going to discuss about the Grignard reagent, right? How it is produced, right? What is the importance of the Grignard reagent and the reactions of the Grignard reagent, right? Okay, first let's discuss about how the Grignard reagents are to be produced, right? So Grignard reagents can be produced. Grignard reagents can be produced, or Grignard is produced. By adding magnesium in dry ether medium to an alkyl halide. This is how the Grignard reagent will be produced. So it's like this. So you could come up with an alkyl halide like this. Okay. So if you add magnesium in dry ether medium, you will produce the Grignard. Right? This Mg comes in between the carbon and bromine, right? This is the Grignard. This is how the Grignard reagent is produced, right? So this is your alkyl halide. This is your Grignard reagent. This is the simplest way of producing the Grignard reagent, right? Okay. To alkyl halide, you can add the magnesium in dry ether medium to come up with the Grignard, right? So let's discuss what is the importance of this Grignard reagent, right? What is the importance of Grignard reagent, right? Importance of Grignard reagent, right? Importance. Why we are supposed to produce this kind of a reagent, right? What is the importance? The importance is this, if you take this alkyl halide, right? If you take this alkyl halide, it comes to alkyl halides, right? This carbon pair in the alkyl halide is actually electron deficient, right? So you are with a electron deficient carbon. With the alkyl halides. But after you converted that alkyl halide to a Grignard, right? Now your carbon looks like this, no? With some MgBr section. Now the carbon is more electron than magnesium, right? This is 1.2, this is 2.4. So the electrons are attracting towards the carbon. So now your carbon is electron rich. The Grignard reagent, your carbon is electron rich carbon. So you are able to convert to alkyl group, right? Convert to alkyl group, convert the carbon of alkyl group from electron deficient carbon to an electron rich carbon by forming a Grignard reagent, right? By forming a Grignard reagent, the alkyl halide is a Grignard, no? Right? So what you can do is, what you are doing here is converting the carbon of the alkyl group from electron deficient carbon to a electron rich carbon. See, to electron rich carbon. Right? That is what the Grignard do, so that these electron rich carbons can be used to attack to electron deficient carbons in your organic compounds. So these electron rich carbons can be used to attack to electron deficient compounds. So after making Grignard reagent, this electron rich new delta carbon can be used to attack delta positive carbons of organic compounds. Right? So such carbons are appearing with the aldehyde ketones. See? With aldehyde ketones, you will see such carbons, delta positive carbons. No? To those carbons, to attack those carbons, the Grignard can be used. Right? Even with the acid chlorides and the esters, those are with electron rich carbons, sorry, electron deficient carbons. To those electron deficient carbons, that can use as a reagent to attack to those. So this electron rich carbon center will attack to those electron deficient carbons. Right? So that is the usage of Grignard reagent. You had converted the electron deficient carbon of alkyl group to electron rich carbon by forming a Grignard reagent. Right? So that is the importance of forming Grignard reagent from alkyl halide. Now your alkyl group can be used to attack to a electron deficient carbon in other organic compounds. Right? The idea is clear, no? Right. Those things are mentioned in your page number 11 of etude. Let's go to that. Right? Okay. Let's come up with the next thing, right, which has been discussed with the note. Right? So we had told you that Grignards can be made by alkyl halides. That is clear. That can be made by alkyl halides. But keep that in mind, not all the halogenated compounds, not all the halogenated organic compounds are able to form Grignard. Right? Let's discuss about that idea. Right? So let's write that thing first of all. Grignard is formed by reacting magnesium in dry ether medium with alkyl halides. right? But this is important, but keep in mind, not all the halogenated organic compounds are capable of forming Grignard. By reacting with magnesium dry ether. See what this means? Yes, Grignard can be made by alkyl halides when reacting with magnesium dry ether, but not all the halogenated organic compounds are able to do so. Let's discuss about that thing. The point is this, right? So, if there's a positive polar hydrogen or positive polar carbon is appearing if there is a positive polar hydrogen or positive polar carbon is appearing other than the halogenated carbon, from such compounds Grignard can't be made. Cannot be made. Right? Let's discuss what this means. See this example. So let's say this compound is there. And you are adding some magnesium in dry ether to this one. Right? Let's say what will happen. So this Mg comes to this section, right? First to form this kind of stuff. I write this thing clearly to get the complete knowledge. But as soon as this Grignard is produced, what will happen? As this carbon is delta negative, as the electrons are coming towards the carbon, that thing will definitely attack to this delta positive hydrogen. Delta positive hydrogen is appearing here. So if there is a delta positive hydrogen, definitely the so produced thing will, that carbon will attack the delta positive hydrogen, right? So what will happen? These things will get connected, right? And when the hydrogen forms that bond with this carbon, the 2 electrons of the hydrogen will be given to the oxygen, right? This thing will also leave. So then I'll write the form, what kind of a compound then will form, right? So these electrons are coming towards oxygen, forming O minus like this, and you have CH2, this CH2, right? okay, and this hydrogen will gain this hydrogen, so this carbon will gain this hydrogen. So already this carbon is with 2 hydrogens, and that guy will gain this hydrogen as well, so it becomes CH3. So released MgBr plus will appear here. So that's it. So ultimate compound, that is not the Grignard region, that is not a Grignard region. Grignard means that MgBr section should be connected to a carbon. That is not appearing, that is not what appearing here. So this is not a Grignard region, right? Even though you have added some magnesium and dry ether to a halogenated compound, you are unable to produce the Grignard. The reason is this: if there is a positive hydrogen or a positive carbon other than the halogenated carbon, definitely, right, you can't form a Grignard. As soon as the Grignard will produce, it will react further, right, with the delta positive hydrogens and delta positive carbons, so that you are unable to come up with stable Grignard compounds with such compounds, with such halogenated compounds, right? That is one example, right? I'll come up with another example. I'll come up with another example here, right? So let's copy this one. Another example for the same idea, right? The second thing given in your tute, you are with this kind of a compound, no? Right? So to this one, you are adding magnesium in dry ether medium. Let's see what will happen. So basically, at the reaction medium, first this kind of stuff will produce. Right? The MgBr section comes to here. As soon as this thing is produced, what will happen? As this carbon is delta negative, as the electrons are coming towards that carbon, and this carbon is delta positive, as soon as this thing is produced, this thing will attack to this one, right? So with the use of electron pair here, this thing will attack to here, this one, right? So that these electrons will move like this, and when carbon forms a new bond, carbon will leave the bond with the MgBr. So MgBr had to leave, right? So MgBr will leave, right? So what would be the ultimate compound then? So what you would observe practically is not this one, but this kind of a compound. Then you have CH2, CH2, and this carbon which is connected to this one, I'll write it here, which is with 2 hydrogens, now will be connected to this carbon, right, like this. So the MgBr left here we come up as MgBr plus, right, because these electrons are going to given towards the carbon, so this becomes plus, no, magnesium. So you can write that thing as like here like this. So this is the compound ultimately which will form if you add the Grignard to this kind of a compound. See, that is not a Grignard region, right? Grignard regions are the ones where the MgBr section is connected to a carbon, right? Not like this, right? So this is not a Grignard region. So you are unable to produce Grignard regions if you have delta positive carbons or delta positive hydrogens in your compound. So here delta positive carbon is there with your halogenic compound, so you can't produce the Grignard like that. So these are the 2 carbons there, right? Okay. If you copy the 1, 2, I just labeled to identify the 2 carbons correctly. Is a cyclic compound, right? So that is the idea, right? You can't create a Grignard reagent if your halogenic compound is with a delta positive carbon or a delta positive hydrogen, right? If you are with a delta positive carbon or delta positive hydrogen, right, you can't come up with a Grignard reagent by adding magnesium right to that thing, right? So that idea should be in your mind. That is something which will be frequently asked in your A-levels, right? Okay, those are the things appearing in the page number 11 of your tute. Just go to that, right? I think the ideas are clear there, right? Okay, so after learning these things, right, of the Grignard reagent, right, let's try to discuss about the reactions involved in the Grignard reagent. The reactions involved in the Grignard reagent, right? As we have seen with these examples, with the 2 examples we had discussed, the carbon of the Grignard will attack to delta positive carbons as well as to delta positive hydrogens, right? Okay, so there are 2 types of reactions then with the use of the Grignard. We have the Grignard attacks to delta positive hydrogens and we have the Grignard attack to delta positive carbons, right? Let's discuss about those 2 types, the reactions of Grignard reagent, right? That is our next topic. Reactions of Grignard reagent. Right. First thing, as I have mentioned earlier, there are 2 kinds now. First thing, actually when Grignard attacks to delta positive hydrogens, those reactions are referred to as the reactions via Grignard reagent involving as a base. Attacking to delta positive hydrogens means it's a base, right? Okay, so Grignard as a base, yeah, Grignard attacks to delta positive hydrogens in compounds, right? See these examples. Grignard as a base. So these are some examples. So if you think of these things, right? Even the ammonia, the alcohols, right? The carboxylic acids, right? So what else? The phenols, right? Even the aniline, is terminal alkynes. Actually, all of these compounds are with delta positive hydrogens, right? Because these hydrogens are connected to a because these hydrogens are connected to highly electronegative atoms, you see, to the nitrogens or oxygens. These hydrogens are connected to highly electronegative atoms, right? Even this hydrogen, because it is connected to sp carbon, right? As these things are connected to highly electronegative atoms, these are positive pole hydrogens, highly positive pole, delta positive hydrogens. So that if you add some Grignard reagent, definitely that Grignard reagent will attack these hydrogens, right? Let's come up with those reactions then. Right, all of these things with Grignard will ends up with some Grignard attack towards the hydrogen, right? Let's discuss. Let's use this Grignard reagent, right? C2H5 MgBr. If you use this Grignard reagent, what will happen? This hydrogen will be grabbed by the carbon which is connected to magnesium. So ultimately what will happen? Right? This hydrogen will connect to that carbon. This hydrogen will connect to that carbon, so that you will produce the alkane. You will produce the alkane. It's like this, Nilama. If you need some more clarification, right? It's just this now. So I can write this compound, right? Write this here. Is this now? You have CH3. This H thing is there, and this MgBr no, right? This carbon is delta positive no. So what will happen? Right, this positive carbon will attack to this positive hydrogen. Sorry, this carbon is negative, right? Okay, sorry, this carbon is negative now, right? So that this negative carbon will attack to this positive hydrogen. Ultimately what will form? CH3, CH2 will be combined with this hydrogen. So CH3, CH3, C2H6. So the alkane of your alkyl group of the Grignard will form. Alkane of the alkyl group of the Grignard will form, right? This is the alkyl group no. It's the alkyl group of the Grignard no. Alkane of the alkyl group of the Grignard will form. See, C2H6. Even in these cases, the same thing, as the same Grignard reagent is used, the same alkane will produce. Idea is clear? Alkane of the alkyl group of your Grignard will produce. If Grignard is added to a solution with positive pole hydrogens, right? So what will be the product of the other side? So you could think of this kind of thing as well. When the alkyl group connects with these hydrogens, right, this MgBr section will connect with the rest of the compound. The MgBr section will connect with the rest of the compound. So we can write it as as hydrogen leaves by giving the electron pair to these electronegative atoms, no? Right? So that the electronegative atoms will come up as minus charged species, right? So minus MgBr, right? So that this Br will leave, MgBr will leave by giving the electrons to carbon, no? So MgBr plus, right? That is how the compounds are formed. This in this case, this is NH2 minus the MgBr plus. This one RO minus MgBr plus. This case RCOO minus MgBr plus. These things will be asked, right, in MCQs basically. These ones as well will produce. If it is with the phenol, you will come up with this one. If it was with the aniline, you will come up with this one. What about this one? So this will produce some special compound referred to as the acetylene Grignard. Is very special, na? Referred to as the acetylene Grignard. Referred to as the acetylene Grignard. It is another kind of Grignard reagent, right, which can be used to attack to delta positive carbons. Acetylene Grignard, right? Acetylene Grignard, right? So these are the reactions where Grignard involves as a base. Grignard involves as a base, right? The idea is clear, no? Grignard involves in these reactions as a base. Why we consider Grignard as a base in this case? Because that Grignard is attacking to a delta positive hydrogen, right? If your reagent is attacking to a delta positive hydrogens, right, your reagents are referred to as bases. We had discussed that same thing with the elimination reactions of alkyl halides as well. When you are using alcoholic KOH, right, alcoholic KOH, the OH minus will attack to delta positive hydrogen of your alkyl halide. The hydrogen of the adjacent carbon, we are in the halogenated carbon, is with some positive charge, positive nature, electron deficient nature. To that hydrogen, the OH minus will be attacked when you are using alcoholic KOH with alkyl halides. So there also the OH minus is referred to as a base. If your reagent is attacking to a delta positive hydrogen of an organic compound, that reagent is referred to as a base, right? So Grignard here is a base. This negative carbon is attacking to a delta positive hydrogen, right, of your compounds. So Grignard behaving as a base in this case. So that is the first kind of reactions available with the Grignard reagent, right? Okay, let's go towards the next kind, the second type of reactions with the Grignard, right? Second type of reactions with the Grignard reagents, right? The second kind is when Grignard is attacking to delta positive carbons, right? In such occasions, we refer the Grignard as a nucleophile. If you are attacking delta positive hydrogens, the reagent is referred to as a base. If you are attacking delta positive carbons of organic compounds, then a reagent is referred to as a nucleophile, right? The second kind of reactions with the Grignard is Grignard acting as a nucleophile. Grignard as a nucleophile. right? We have Grignard attack to delta positive carbons. That is why it is referred to as a nucleophile in these reactions, right? So such 4 reaction types are available, right? With aldehydes, with ketones, with acid chlorides, as well as with esters. But if you react the Grignard with these guys, Grignard will attack to the positive carbons of these compounds. These carbons are positive, right? As the electrons are attracting towards the more alternative oxygen, these carbons are positive. So towards these positive carbons, your Grignard reagent will attack, as it is bearing a negative carbon, electron-rich carbon, right? See, you are using this Grignard reagent. Right? As this carbon is negative in your Grignard reagent, as the electrons are coming towards the carbon there of the CMG bond, right? So this thing will attack with use of these 2 electrons. That thing will attack to here. This comes up there. So these 2 carbons will get connected by this attack, by this nucleophilic attack towards a delta positive carbon, right? So what will be the end product then? As these 2 carbons are going to be connect with each other, with these electrons coming like this, I'll write the hydrogen here, and this carbon will connect, right? So that is carrying 2 hydrogens, the CH3. So if you need to mark these carbons, right? These are 2 carbons, right? Okay. So we'll come up with these alkoxides if this kind of attack occurs, alkoxides. But normally in reactions, not only the Grignard will be added at the dry ether medium, but with this thing, after the reaction is completed, they will add some acidic water as well. So normally this is the procedure carried out. With the addition of the Grignard, you will produce the alkoxide. When the acidic water is added, this O- will grab this H+. Ultimately, it will produce the OH. Ultimately, it will produce the OH, this H+. Right? Will be grabbed by the O- to produce the OH, alcohol. So only if you are coming up with this hydrolysis part, you will produce the alcohol. If not, it is the alkoxide Grignard will produce, right? So the alcohol, with these guys as well, the same kind of process happens, right? So you will produce alcohols after the addition of H plus H2O, right? So to here the Grignard part will connect CH2, CH3, right? So basically when it comes to aldehydes and ketones, when it comes to aldehydes and ketones, it's aldehyde no? And ketones. When you are referring to aldehydes and ketones, right? You will produce alcohols with one group from Grignard, alcohols with one group from Grignard's alkyl section here, right? So one group coming from one alkyl group coming from Grignard with your alcohols, and one alkyl group coming from Grignard, alcohols with one group coming from Grignard. So with the aldehyde you have 1R group. With the product now you have 2R groups. Secondary alcohol is produced by the aldehydes. With ketones, as you are with 2R groups, alcohols with 3R groups, tertiary alcohols will be produced, right? So regarding this we can say, right, alcohols with one R group, one alkyl group coming from Grignard, right? Okay, those are products when Grignard is to react with aldehydes and ketones, right? Let's discuss what will be the products with the right with the acid chlorides and esters. Right, as these guys are referred to as good leaving groups, and that thing will also leave. These sections will also leave, right? So that not only one group but two groups will be connected from the Grignard. When the Grignard attacks, first these things will leave, right? So to these sections also Grignard group will connect to form the ketone first of all. To that ketone as well the Grignard will attack. So ultimately you will come up with alcohols with two groups from Grignard. One group is also already there in your compound, so altogether three groups will be appear at the end. So tertiary alcohols will be produced with the acid chlorides and esters. Let's copy the compounds then. So the compounds are looks like this. You have this thing CH3, and this becomes the OH. This section becomes the OH. To this section as well as to the basically to the other two bonds. To the other two bonds, the Grignard sections will be connected. Alkyl groups of the Grignard will be connected. Right? Earlier you had the CH3s and hydrogens which can't be released by a nucleophilic attack, but now you have these things which are considered as very good leaving groups. So with the nucleophilic attack these things will easily leave, right? So that all together two groups will connect from the Grignard in producing the alcohols from the acid chlorides and esters. Right? Okay, the idea is clear. So you can say these two groups are coming from the Grignard, right? See, alcohols with two groups from Grignard, right? This is the Grignard's R section, right? So with the acid chlorides and esters will produce alcohols, definitely tertiary alcohols with two R groups, two alkyl groups from Grignard. Right now, that is how Grignard is supposed to react with aldehyde, ketones, acid chlorides and esters, right? Okay, clear? Right. Let's discuss about the mechanisms of these reactions. Quickly, let's go through the mechanisms of these reactions as well. right? So those will be asked in A-level papers, frequently asking questions, right? The mechanisms of these things, right? So keep it in mind. First, when the Grignard is added, the alkoxide is produced. Only after the addition of the H plus H2O, you will come up with the alcohol, right? These hydrogens are connected, actually given by the acidic water, right? Acidic makeup is needed to come up with the alcohol. Remember that thing. You only need these two, right? Okay, let's come up with the mechanisms then. Right. So, mechanism. First, let's come up with the mechanism of this thing. When aldehydes reacts with Grignard, we have aldehyde. So, what is the reagent added? The C2H5, no? C2H5 MgBr is added, right? With dry ether. Then the acidic makeup is also done. So now we know what is the product, right? It is the alcohol with one group coming from the Grignard. The aldehydes and ketones, only one group is coming from the Grignard, right? Okay. So I'll put that group here, C2H5 group. So let's try to come up with the mechanism of this reaction, right? Mechanism. Right. So it would be looks like this. So when writing mechanisms, you are always supposed to display all the bonds with the carbons which will form and which will break the bonds, right? So we clearly see this carbon is involving in bond breaking and bond forming, see? So indicate all the bonds clearly with that carbon, right? So in this case also, the carbon which is connected to magnesium is involving in bond forming and bond breaking. The bond forming is the formation of the bond with the delta positive carbon here, and the bond breaking is the breaking of the CMG bond. So with that carbon also, you have to indicate the bonds clearly, right? So C2H5 MgBr, right? This is the C2H5 section, right? So I'm indicating all the bonds clearly with the Grignard carbon as well, right? Okay. So what will happen? So this bond is polarized as delta negative, delta positive. This bond is also polarized as delta positive and delta negative because of the electron difference. So that what will happen? These electrons will be greatly attached to this carbon and it will attack to this carbon, electron deficient carbon, so that the weakest bond out of the two, which is the 5 bond, will break and give the electron pair to the oxygen, like that. So that you will come up with this at the first, right? So you have the hydrogen and this carbon will connect, that carbon carrying 2 hydrogens, right? Sorry, 2 hydrogens, right? CH2 and connected to another CH2 group, right? So you can write this MgBr as now it is going to be Mg2 plus because this electron is given to this carbon, right? So the pair is given to the carbon, right, which is going to attack to the delta positive carbon here, right? So that MgBr plus could be written here. Or one can write the same thing as OMgBr. You are not supposed to write any covalent bond here, but you can write it like this as well. It's ionic bond actual, right? So after this, what will happen? When you are adding the H plus H2O This O minus will grab this H plus. O minus will grab this H plus to come up as an alcohol. Right now? So this is how the mechanism looks like. Right now? Okay. Let's try to write the same mechanism with the use of a ketone as well. See? Ketone. Let's try to come up with the mechanism of this ketone. You are adding C2H5MgBr right? In the presence of dry ether medium. After the reaction ends, you are adding some H plus H2O. So what will be product? First of all, the product is your alcohol with one R group connected from Grignard. This is the R group of the Grignard, C2H5, that will be connected. Two R groups appeared earlier will also still be there, right? Okay. So let's try to come up with the mechanism of this thing, right? Right? Like in the earlier case, right? Always clearly mention all the bonds with carbons which are participating in bond breaking and bond formings, right? So even the Grignard carbon is such. So we are clearly mentioning those two carbons, right? And we know this case is positive charge and this is negative charge because of the polarity difference, electronic difference of the carbon and oxygen. In this case also, you can see some polarity like that, so that this negative carbon will attack this positive carbon here with use of that electron pair. So when this carbon forms a new bond, the weakest bond will break, that is the 5 bond, right? So with this, we'll come up with this intermediate state. The MgBr will connect ionically here. This carbon, this C is connected, right? So that C is with 2 hydrogens and some CH3, no? Right? So when you are adding the H plus H2O kind of a dill acid, this hydrogen will be grabbed by this O minus, right? To come up with the alcohol. So you will produce some tertiary alcohol where one R group is given by the Grignard. That is this R group, right? So that is the mechanism when the Grignard reacts with the ketone. Right now? Okay. Let's come up with the other two mechanisms as well. Right? Now I am going to discuss the mechanism of the reaction of the Grignard with the acid chloride, right? Let's say you are adding C2H5MgB as the same Grignard we had used so far. Dry ether. After that addition, after the completion of the reaction, you are adding H plus H2 as well, right? So what will product first of all? Now we know how to write the product, right? So we will get an alcohol, and as this one is a good leaving group, that thing also leaves, and instead of other two bonds, right, the R group of the Grignard will connect, right? So tertiary alcohols with 2 R groups coming from Grignard. Product is clear. Let's try to come up with the mechanism here. Right, the mechanism. So again I am clearly indicating all the bonds of the carbons which will break and the form bonds, right? So this is the Grignard carbon, right? So polarities will appear like this. Right? So what will happen? This negative carbon will attack this positive carbon with the use of this electron pair, so that when this carbon forms a new bond, it have to leave one of the existing bonds, right? So the weakest bond will break. The 5 bonds are weaker than the sigma bonds. So the weakest bond, the 5 bond will break first, right? So first you will produce this one. With that attack, you will produce this one, right? That carbon will connect, right? C2H5, you can write it as C2H5 even, right? Okay. Then what will happen? Then, as this chlorine is considered as a good leaving group, when this one connects with your compound, chlorine leaves. When newcomer joins, chlorines are always leaving, right? So as now carbon is lack of 4 bonds, when the chlorine leaves, this pair again coming towards this position to make the 5 bond again, right? So that is how the things occur. To give you a ketone first. So C2H5, right? So this Cl will leave, right? So Cl can be considered as a leaving group here. So you clearly see kind of a nucleophilic attack. This is a nucleophile. Nucleophile and nucleophilic attack, right? And leaving group is there. So it's a substitution. So this reaction is referred to as a nucleophilic substitution, right? The nuclear substitution, right? Earlier 2 reactions are nucleic additions, but in this case it's a substitution. So you clearly see the Cl leaves instead of someone, right? The new group is added, nucleic substitution, right? So what happens ultimately? So the reaction won't stop at this stage. After producing the ketone, that ketone will be further attacked by the excessively added magnesium bromide. The magnesium bromide will be still there in a solution, right? So those will attack so produce ketones, right? So that this attack will occur. So same kind of a electron transfer occurs. The weakest bond will break. This is same as the mechanism. This part is same as the mechanism we had discussed with the ketones, right? Right. Ultimately, when you are adding H plus H2O, right, this will form two groups from the Grignard. Tertiary alcohol with 2 groups from Grignard. Right now, that is the mechanism. Right. Okay. So if you have to think of the mechanism with the esters, So very little things to change here, the same kind of mechanism with the esters as well. So what differs is actually, instead of the Cl part, the OR part comes. Right? Let's do that thing as well quickly. Right? Let's do the mechanism for this one. Let's see, you are with this thing and you are adding this thing to your ester. Right. So you will produce some tertiary alcohols with 2 R groups coming from the Grignard, right? Let's quickly discuss the mechanism there. This is what happens, right? So, like in the acid chloride situation, Grignard will attack this delta positive carbon of the ester, right? So the polarities are like this. Due to the differences, right? So Grignard will attack like this, and the weakest bond will leave. That is the 5 bond. So with this, we will come up with this intermediate compound. And this case as well, the OCH3 is referred to as a good leaving group. This is referred to as a good leaving group. When newcomer connects, leaving groups will leave easily, right? Like this, as electrons are attracting towards the oxygen. So that as carbon is lack of 4 bonds, these electrons will be given to this space again to fulfill the octet, right? The 4 pairs. So with this, you will form the ketone again. And this part will leave as O minus CH3. So it is considered as a leaving group in this case. So again, you clearly see you have a nucleophile here which is attached to the positive carbon. Right? Leaving group is there, so we can consider this one as a nucleophilic substitution. Sorry, it's a substitution, no? Nucleophilic substitution. Reaction mechanisms involved in the acid chlorides and esters are referred to as nucleophilic substitutions, while the aldehyde ketone mechanisms with the Grignard are nucleophilic additions. Right? After forming that ketone, as ketones are always attacked by the Grignard, the positive carbons of the ketones are always attacked by the Grignard, such kind of attack occurs with the remaining Grignard reagent of the at the medium, right? This is again same as the mechanism of Grignard with the ketones. So first you will produce this thing with some MgBr part appearing with the ionic bond with the oxygen. Then when you are adding H plus H2O, right, that alkoxide will convert to alcohol. . 。  . 。 . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . right? When you're adding H plus H2O, this leaving group will also convert to a alcohol, no? Just mention that thing as well. So 2 alcohols will be produced by the reaction of, right, esters with Grignard after the acidic makeup, right? Is a leaving group, no? That is also convert to alcohol. 2 alcohols will be produced. One alcohol coming from the from the OR group of the ester, and the other alcohol coming from the R group of the ester, right? Sorry. So that is the mechanism, right now. The thing is clear, no? Right. So with this, we are going to wind up the section with the Grignard, right? Let's go through these things. Right? These are very important mechanisms which will be frequently asked in the A-level paper, right? Even in the MCQs, right? Okay. So let's wind up at this stage. We'll meet with the next lesson soon. Goodbye then.